Hi, this is Mrs. Wiederholt, and welcome to my lesson video on conic sections, ellipses. Now let's get started. There are two types of ellipses, vertical and horizontal. Each type of ellipse has a major axis and a minor axis. The major axis is always the longer axis, and the minor axis is always the shorter one. In the vertical ellipse, the major axis is vertical, and it cuts the ellipse into two equal halves. Now in the horizontal ellipse, the major axis is horizontal, and it's this way that it cuts the ellipse into two equal halves also. Now let's talk about the minor axis. In the vertical ellipse, the minor axis is the shorter one, and therefore it's the horizontal axis. And in the horizontal ellipse, the shorter axis is vertical, and so the minor axis is the vertical line. Now what's important about both types of axes, the major and the minor, is that they cut the ellipses into two equal symmetrical halves. Therefore, the equations for each axis are the only lines of symmetry for ellipses. Now, there are two variables that we need to understand what they represent. The first is A, and A represents the distance from the center to the edge of the major axis. In the vertical ellipse, that would be this segment right here. See, I'm going from the center up to the edge of the major axis. And in the horizontal ellipse, we start at the center and it would go to the edge of that major axis. B represents the distance from the center to the edge of the minor axis. So in the vertical ellipse, that would be from the center to the edge of that minor axis, right there. In the horizontal ellipse, that would be from the center to the edge of the minor axis there. Now let's look at the equations for each type of ellipse. The equation for the vertical ellipse is y minus k squared divided by a squared plus x minus h squared divided by b squared equals 1. The equation for the horizontal ellipse is x minus h squared divided by a squared plus y minus k squared divided by b squared equals 1. Now in each of these equations, the h and the k value represent the center of each ellipse. Now let me tell you how I tell these two equations apart. Now when I look at this first fraction right here, it's the y minus k that is paired with the a. Now remember, the a value is the distance of that from the center to the edge of the major axis. So when you have that major axis paired with what we know to be vertical, remember k value has to do with range. Y and k have to do with the range, which is vertical. So when I see the major axis paired with the vertical y and k, that tells me this is an equation for the vertical ellipse. Now likewise, when I see that the major axis, which is represented by A, is paired with the x and the h, which represents domain, that's horizontal. So that's how I tell which equation goes with which ellipse. Now let's look at an example. We are going to graph and identify the characteristics for x squared divided by 16 plus y squared divided by 36 equals 1. First, we can identify the center. Now remember, the center is the h and k values. So that means for this equation, our center is 0, 0. And so let's go ahead and graph that. It means the center of our ellipse will be at 0, 0. Now, in order for us to determine our vertices, we have to know what our a and b values are. So let's go look at the denominators. Now, 36 is my larger denominator. And so remember, this denominator in the equation would be a squared. So if 36 equals a squared, that means a equals 6. Now let's do the same for the other denominator, which would be our b. If 16 equals b squared, then b equals 4. Now since a represents the distance from the center to the edge of the major axis, we can count up 6 units from the center. So that would, if we start at 0, 0, that means we would count up 6 units. 6 units. And then from the center we can count down 6 units. So basically what we've just created from positive 6 down to negative 6, that's the length of our major axis. Now these 2 points are also our vertices. So let's write the ordered pairs for these 2 points. The first one is 0, 6, and the second one is 0, negative 6. Now we are going to find our covertices, which are the vertices for the minor axis. We will use our b value, which is the distance from the center to the edge of the minor axis. So since our b value is 4, we'll start at the center and we will go left 4 units, and then we will go back to the center and go right 4 units. So our covertices are negative 4, 0, that's the first one, or the left one, and 4, 0, that's the right one. Now we are ready to sketch this ellipse. So I am not very good at this, but I always give it my best shot. So there we have our vertical ellipse. Now let's determine the length of our major axis. Well, let's think about this. If the a value is 6, that means that 6 times 2 would be the length of our major axis. So that would be 12. Now another way you could do this is you could literally count it on your graph. We could start here and go up 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 2 ways. If you have a graph, you can count it, or you can take the a value and multiply it by 2. So what would the length of the minor axis be? Well, if you guessed 8, you would be correct. Because 4 is the distance from the center to the to the edge of the minor axis, and that means it goes this way and this way. So total, that is 8 units. Now let's write the equations for our lines of symmetry. Now if you remember on the previous page, I told you that there would be 2 of them. First, there is the vertical one that will cut it in half vertically, and then there's going to be the horizontal one that cuts it in half horizontally. Now remember, both of these lines of symmetry, they have to go right through the center of the ellipse. So the equation of our first one will be x equals 0. And our second equation would be y equals 0. Now also, if you don't have a graph to look at, your vertical line of symmetry will be x equals the h value, which is up here, your center of your circle, the h value. Or in your equation, it would be up here if it were in parentheses. And then the horizontal line of symmetry would be y equals the k value, which could be found here in your center, or if there was a parentheses, it would be found in the parentheses with the y. Now let's look at the domain. The domain will be the x-coordinate of the left vertex to the x-coordinate of the right vertex. So it will look like this. It will go from negative 4 to positive 4. Now let's look at the range. The range will start with the y-coordinate of the bottom vertex and end with the y-coordinate of the top vertex. And so it will look like this. It will go from -6 to +6. Well, I hope this video has helped you understand a little bit more about ellipses, and I look forward to working with you again. Bye-bye.